All right, perfect. I'm going to go ahead and start. Hopefully everybody can hear me. Sorry, I don't speak Russian. But I'll try to speak slowly so we can talk about it. You're going to spend with me the next hour talking about Universal Windows games. For context on who I am, my name is Jaime. I actually come from Redmond, Washington. And during my day job, I actually spend all my time talking to major publishers, people like King or Zynga or Disney, and I actually help port all of their games to Windows. So if you have a game and you want to move it to Windows, usually you work with somebody from my team in helping you bring your games to Windows. So today I'm going to spend the hour talking to you about a little bit of what it is like to bring a game to Windows. If you have an iOS game or if you have a Win32 game, or an Android game, you should be able to pretty quickly understand what it takes to bring your game to Windows. So that's kind of what we're going to start talking about. Now, we're going to talk about it in the context of the... Is this too loud? Is it too loud? Okay. In the context of the Universal Windows platform, which is a new platform that we have for actually writing games that actually run on the Xbox, HoloLens, PC, and Windows Phone, and Surface Hub. So pretty much what you're going to see today is you're going to see a game where we can write a game once, and then we actually get to deploy the game everywhere in your PC, in your Xbox, or your phone. So for example, right here, if I show you this, to give you a context, this is a Universal game, and what I have right here is one game that I can come back and I say, look, if I have, just a standard game, it's a little monster game, kind of like Pac-Man, that we use for teaching people how to write games. And I can come back here and say, hey, let's go ahead and run this game just on a PC, right? So I can come right here, and I'm in the debugger running my game, and you'll see in a minute the game comes up, and it's a game that runs fine on PC. And here I'm using mouse and keyboard to run the game, so I can actually see, you can see my character move around and everything else the way you would do it. Now that same game right here, without modifying it at all, I can come back here onto that exact same game and just change the device, the target device right here, and I'm just going to say, instead of running it on the, on the device, on my PC, I want to run this game on a Windows Phone. And in this case, I'm going to run it on an emulator so that you can actually see it running on the screen. And you can see right here is the exact same game running on Windows Phone. In fact, I'm using the emulator here. So one thing that I can do is actually use my keyboard here to play the game. So I can get around here very similar and play the exact same game without any modifications. Game is running on Windows Phone. And you can see here, I can play the game, and it's the exact same gameplay and everything else. And then finally, if you want to see it run on Xbox, all I have to do is come right here and change here my target device from being a mobile phone to being my Xbox. And for that, I'm just going to say, hey, send it to a remote machine, which is going to be the Xbox. This is my IP address for my Xbox. And then if I change right here my console, you will see that if I just click remote machine, you'll see the game come up right here on Xbox, and I can be able to play the exact same game on the Xbox with a controller. So earlier you saw me do it, I was doing it with mouse and keyboard. Now I can come back here to the Xbox and then see the exact same game, and it's taking a little bit to deploy because I'm deploying it over Wi-Fi. So it should come up in a minute. Let me double check. Yep, it's coming up. And you'll be seeing the exact same game running right here on the Xbox. Exact same menus using the controller. I can actually just go ahead and play. And it's hard to play without seeing it, but let's see if I can move around here. So you see the exact same game running around here on the Xbox. And I didn't have to touch anything. I didn't have to modify any of the code, and the game runs everywhere. In this case, this game is actually written in Unity, so if you wanted to, you could, of course, also take the game to iOS or Android. So it's very easy for you to actually write portable games that run across all of our devices and can actually run on iOS and Android and any other mobile devices. And that's what we're going to spend the next hour talking about. How to build these kind of games, what kind of things to think about, and what are the technologies that we use to building this kind of game. So let's go ahead and start with that. So if you want to write a Windows 10 game, which is a universal game, what you're going to need is pretty straightforward. You need to be running Windows 10. That is free right now. If you have a Windows 7 or Windows 8 license, we give you a free license to upgrade to Windows 10, so that's pretty easy. You need Visual Studio. Hopefully here everybody's familiar with Visual Studio. I'm going to talk about it in a minute, so you'll get a little bit of an idea of what it is. And it's also free. We have a community edition where that you can use to write any game you want. All of the capabilities that you need to write a game, to debug it, to do the performance troubleshooting and everything are available in Visual Studio community, so you don't have to pay anything to do that. And then finally, if you want to submit it to the store, you will need an account, and that's the very last step, and that's the one step where you actually have to pay a little bit. An account is only $20 US, so it's pretty easy. And if you know somebody from Microsoft, like the evangelism teams that are here talking to game developers, you should be able to get a free account from them anyway. So that's what you're going to need. So with regards to Visual Studio, for those of you who haven't seen it, hopefully everybody here is familiar with Visual Studio, the compiler, right? You've seen it before? So great. So with regards to Visual Studio, I do want to highlight a couple of things that we've added. Most of the people, whenever I talk to them, they think of Visual Studio as a great code editor. They know that it has a great debugger. It's a great C++ compiler. And we've added a lot of functionality in the last year. So one that I want to highlight is with Visual Studio today, you can actually start writing iOS and Android code and compiling it and even debugging it from within Visual Studio. Again, the community edition, the free edition, actually has this capability. We've added all of those capabilities. With regards to game development, we also added a lot of features in the last year. We added a graphics debugger, something where you can go in there and capture frames. You'll see a screenshot in a minute. You can go in there and do GPU and CPU profiling. We've actually acquired a company that used to be called UnityBS. And we acquired it and integrated it into Visual Studio and into a new product called Visual Studio Tools for Unity. So we've been adding onto the Visual Studio SKU a lot of free features that you'll be able to use for actually doing game development. For example, one of the other issues that we've added is we've added a lot of new C++ conformance improvements. So if you're familiar with the standards, like there's C++ 11, which has been around for a long time. And that one we've been working on, but with Visual Studio 2015, we've actually added a huge amount of functionality to make sure that we're conformant with C++ 11. We went ahead and added a lot of functionality to make sure we're conformant with C++ 14 too. And then we've also started on C++ 17 already. So we feel that our compiler is very, very modern. We feel that we're keeping up with the standards very well. So on that side, if you want to check out Visual Studio, you should be able to write very modern code with great conformance across platforms with our C++ compiler. Here's a screenshot of our graphics debugger that's come with Visual Studio. With the graphics debugger, you can actually go in there and capture frames within your game. So you're actually playing your game, you say capture a frame, and then you can go in there and see event history, the pixel history, how the shaders, how everything came together such that we drew a pixel onto the screen. So you'll be able to actually visualize everything on how it was drawn and actually replay that back if you want to troubleshoot an issue, you'll be able, with a graphics debugger, to replay that frame back even after you've run your game. We've also added a very basic model and mesh viewer. So if you have a 3D model and you just want to rotate or transform something, you can actually do that from within Visual Studio. It's not the most comprehensive. It's not an actual model or mesh editor. It's mostly a viewer where you can use for rotating stuff around, but you can actually use that pretty well. We've also give you a new shader designer. This one is interesting because it actually shows you the history of pixels. So if you look at how you drew something on the screen, you can look at the whole shader pipeline and look at every stage of the pipeline and see, oh, this is what happened at this stage in the pipeline. So that's what the shader designer do, and that's what it's useful for. So it's great for you to actually visualize and troubleshoot any kind of problem that you're looking at. Along with the shader visual designer, we actually give you, of course, an HLSL editor and a compiler. And our editor now, he has syntax highlighted, so you'll be able to actually very quickly visualize and see the code and write very well-formatted code from within our HLSL editor instead of just writing it in Notepad++ or something like that. So that's what we've added on the feature, on the tooling. Hopefully everybody here has seen Visual Studio before, so you have an idea of kind of what you're expecting out of it. You have really great tools. Again, they come from free on the community edition, so you'll be able to understand that pretty well. With regards to the platform, what you saw earlier was one game that runs across 3 platforms. So what we've done there is we actually have a new UI platform that we give you, and we give you DirectX, which is what most people use to write their game, but we also give you SAML or HTML as an option for you to write your UI. And then we give you a new application model that's kind of a sandbox application model. If you're familiar with iOS or Android, it's a very similar application model where you're actually running inside a sandbox. You actually have a limited set of APIs that you can restrict, that you can call, and that makes the applications more secure. So it's a little bit different from just running Win32. If you wrote a desktop game before, running to the Universal Apps is a little bit different. But at the end of this presentation, I'll show you how you can take your Win32 game and actually bring it to Universal anyway. So, so we have the model to do both. With regards to the platform APIs, we give you pretty much everything that you would expect. If you're coming from Android or iOS or even desktop, everything that you would expect is there, right? If you're looking at graphics, we have very rich Direct 2D, Direct 3D interfaces for your graphics. If you're looking at something like devices, APIs, we have everything that you would expect, like sensors, geolocation, proximity, all of the stuff that you would expect out of any device, any other platform you would actually be able to get. So we feel we're very competitive with regards to like iOS or Android being able to make sure we give you the exact same APIs or equivalent APIs to they have. Push notifications, local notifications, all of the APIs that you expect are going to be there. So the platform should be familiar to you in that if you're coming from any other place, you should be able to find equivalent APIs, even though they might be different than the ones you're looking at. Diving into how we do a lot of that, here's the kind of more details on what happens at each one of the levels. So for your graphics, you will be writing a Direct3D 11 API. If you've written Win32, you're probably familiar. We have mostly 2 application models right now. We have a Direct3D 9 and a Direct3D 11. Direct3D 11 is actually the one that we use, and it's a different API set than Direct3D 9. So if you have an older game, you will have to convert it a little bit to Direct3D 11 if you want to use the new modern graphics. You can also use Centennial to keep the old API if you want to, but if you want to take advantage of the new one, it's Direct3D 11. And what we do here is with this API set, we give you compatibility across all of the devices that I mentioned earlier. So HoloLens, phone, Xbox, everything is actually running against Direct3D 11. That's how we take advantage of it. Of course, we still have feature levels. So if you're actually writing a game and it's actually running on a phone, you're going to have a little bit different graphic capabilities than if you're running on a PC. But with Direct3D APIs, you can actually detect what capabilities you have. And if you don't have it, for example, the software, the driver will default to doing something in software. So if you try to use a shader that's not supported by the hardware, we will actually default to doing that, doing software rasterizer and giving you compatibility such that your graphics will still work. Performance won't be as great, so you should check and make sure you do the right thing. But it's actually, we guarantee you that the things will drive, the graphics will actually run and not crash, so you'll be fine with regards to writing your game. If you're looking at more modern, if you're looking at the graphics stack still, you should know that obviously Microsoft has been investing a lot into DirectX 12. I think there's a full hour session on DirectX 12 today or tomorrow. So what you should understand of DirectX 12 is that it's going to give you a lot more power, a lot more CPU and GPU control. So with DirectX 12, what we do is we tell you, okay, here's lower-level APIs that you can use to actually do exactly what you want. You don't have to adhere to our pipeline. You can actually have a lot more control over that pipeline, and that way you're going to get a lot more performance out of the GPU. We also give you more instruction sets such that you can do more things like better batching and better sending the instructions onto the GPU. And with that, of course, you're going to get a lot better performance. For the most part, whenever we're seeing DirectX 12 games, we're seeing anywhere from 20% to 50% improvement on the GPU. We see about 20% less, power consumption on most DirectX 12 games if they're being coded right. So overall, it's going to be a huge performance improvement if you're willing to do a little bit of that extra work. With DirectX 12, Microsoft has shipped it for a year. We've actually seen a very huge uptake with regards to AAA games. For example, Battlefront uses it, Quantum Break uses it. There's a lot of games that are already using DirectX 12, so they're coming. The APIs are coming into mainstream, and there's a lot of GPUs that support it today. So if you're running PC games, taking advantage of DirectX 12 is probably pretty safe by now. One of the things that's also coming on graphics is HDR. If you're familiar with HDR, it's kind of a new standard where people are actually with regards to TV and high-end graphics, people have been debating a lot between is the next thing 4K displays? From a Microsoft standpoint, we think that the next technology that we're investing into is HDR. With HDR, you actually get much better graphics than you get with 4K. You actually get much more control out of it, so it actually, for stuff on TV, looks a lot better with HDR than it does with just 4K displays or HDR technologies. So that's what we're investing into now. And one of the things that we've done is in March 2016, if you're writing Xbox console games, we already shipped previews of the APIs for HDR. In Windows 10 anniversary, which is the next version of Windows, it's going live, it's going to RTM this summer. It's still called Windows 10, or it's still Windows 10, but it's we call it Anniversary Edition. That's the kind of the name we give to that release. There's also going to be HDR APIs there. And then we expect that those APIs are going to take us probably the next 9 months or so to get solid. We're also waiting for a lot of those TVs that can actually support HDR. So with regards to you running an HDR game, we would tell you, hey, you can get started now, but expect that you'll be there'll be mainstream devices for you to use HDR next year because there's not as many today. If you're writing physical-based rendering, that's very close to using HDR. The functionality is very similar. So if you're actually if you're writing PVR games today, those are very, very easy to port to HDR. So you'll be able to take advantage of the higher-end graphics relatively quickly. Moving on from what we do at the graphics stacks, how we do the pixeling. There's a couple things you need to know with regards to universal apps, and one of them is the windowing models that we have. With universal apps, the user is always in control. So, if you look at the app that I showed you earlier, you could get that app into full screen, but the user actually has control over resizing the windows. So where traditionally, if you've written a Win32 game, we're used to, hey, we write a Win32 game, we just take over the whole screen and draw full screen. With universal apps, we actually want people to have a window, and the user always has the ability to be able to resize something. So there's kind of 3 modes that you should think about. Your game can be windowed, in which case the user can resize you, and there'll be some control that I'll talk about in a minute. Your game can be full screen, so that's the default where most of us, when we write a game, that's how we want to play. But again, the user will be in control. And then we have a third mode, which is the user is, you actually launched your game and you try to get into full screen, but the user said, no, I want to have my window Chrome, and you will actually see a little bit of a Chrome around your window. And that's something that you don't control. So when you write your game, you should take advantage, or you should be aware of all these APIs, or all these different states, and then just go to the APIs. We do give you APIs to enter and exit full screen. Again, we do give you, we give you an API where if your game launches, you can just say, hey, I want to run on full screen. We give you an API where you can say, hey, my game should not run under windows that are smaller than this size. So you can say, hey, here's my minimum size. And again, we will respect that. And we won't let the user resize beyond that. But in the end, the user will play around with your windows. So make sure that you don't force any kind of behavior like forcing full screen the way we do in Win32. Doesn't work as well on universal games. The user can actually do more, and then your game can get into a weird state where it might be rendering, or it might be clipping if the user is rendering a little bit different. So just don't hard code any behaviors. Another thing that you should know, because we're running universal games, games that run on PC and Xbox and phone. You might want to run a game that uses sensors, or you might run a game that says, "Oh, I want my game to be only on portrait only." And if you take a portrait-only game and if you run it on a phone, that's easy because they have a sensor and we have an orientation. If you run that same game on a PC, well, there's no sensors if it's a regular PC, so therefore we will just kind of default to landscape. So make sure if you're looking at orientation and sensors, make sure that you plan for what's the behavior going to be. For the most part, you get a window and you get told what the screen size you have, and then you'll be able to render against it. But it's something you need to be aware of. The next thing that you have to think about when you're writing a universal game is how you're going to do input, right? If you look at the game that I showed you earlier, I showed you a controller right here. I showed you, keyboard and mouse when I was running it on the PC. And if I was running it on my phone, I would have been doing touch. So you have to think about, hey, how can I do input? And if I want to write a universal game, you should probably handle all different kinds of input. Keyboard, gamepad, sensors, everything else. So how we do that is pretty simple. First of all, if the user is running, touch or mouse or a pen or anything that looks like a mouse input, we actually just aggregate into one API. We call it a pointer API, and the API looks exactly like the mouse API that you're familiar. So if you've written a Win32 game before and you're familiar with mouse down, mouse enter, mouse leave, all those APIs are there, and we just aggregate them as a pointer. So you don't have to worry, you don't have to learn anything about touch, you don't have to learn anything about actually using a pen. You just code to this pointer API, and everything's taken care of. Later, I'll talk about middleware, and then obviously, if you're using a middleware, they take care of it for you too. So with regards to touch, mouse, and input, it's pretty simple. With regards to text input, we actually give you control of input planes. So you actually have APIs where you can say, oh, please show an input plane now, which is very useful for you. Like if you've ever written a game in Win32 and you have to write your own input plane, it's kind of a pain. You spend a lot of time writing something, and then it hardly ever works if you go to localize it to different languages and you have to worry about different inputs. What we do for Windows is we just give you our, same input pane that you would have for Windows, and you have control to show it. You have control to listen to the keyboard events from there, whether it's a soft keyboard or whether it's an actual hardware keyboard. It's seamless to use, so you don't have to worry about how you're doing text input from within your game. So that we make it very easy for you. With regards to controllers, Microsoft has created this new API called Gamepad, and it's in Windows Gaming Input Gamepad. It's a whole new API that we're bringing onto Win32 and onto universal games. So if you're familiar, if you've ever written a console game, Gamepad looks exactly the same than it does on console. So it's more powerful than the X input APIs we used to have for Win32. The API is actually written in the new, APIs that we call WinRT. Those are the new APIs that we use for calling stuff from Universal Games. But what we've done is we have this new, API or this new DLL that you can use that we call X input UAP, and you can use that for when in your Win32 games. So if you want to if you're using controller in your Win32 games today, you can use this new DLL called X input UAP that gives you the same API that gives you access to the same API that we use for WinRT games, for universal games, has more capabilities than X input, and it gives you a very similar API model to what you have to what you are familiar with from X input. So you don't have to migrate your code, you don't have to rewrite your code or anything like that. So that's what we do for X input. With regards to universal apps, we give you access to our store, and this is actually going to take me a whole hour to go through tomorrow, but we give you pretty much every possible thing that you could think about how we monetize, every possible thing that you could think about engagement and everything else. It's coming onto this universal platform. So we've taken all of the APIs that we had on Xbox, things like bundles, things like sales, things like pre-orders, and we're actually added it onto the Windows Store, and we made it available for you on PC, mobile, and Xbox. So we actually give you one API where you can do everything. And again, tomorrow at noon, right here, I'm going to spend an hour talking about all of the things that we have on the store. So I'm not going to dive into them as much today. But you should come tomorrow if you're interested on how to monetize your apps. So that's pretty much the foundation of how you're going to write games. Now, for the most part, everything that I just showed you there, very few people are going to still code games to DirectX, right? You're going to have some sort of custom engine that either you build or some sort of middleware that you would use to actually write your game. So let me tell you where we are with regards to support for middleware and everything else. So of course, there's Unity. It's probably one of the more popular game middlewares today. And for universal apps, it requires Unity 5.2. So if you're still on Unity 4.7 or 4, and you haven't moved to 5, we do require that you actually move to Unity 5.2 or later, and you can actually use that to make sure that, or to write universal games. Actually, how we build is very similar to Xcode or to iOS, where you go into Unity, you say, build, and then you create a project, and then from there, we run a project that we compile against Visual Studio, and then you get a universal app out of there. The APIs are exactly the same. So feature compatibility, editor is very compatible. Everything that you would expect is Unity. So they make their money from making sure that the games are very portable. So on that side, you're very safe. On our world, you're running on .NET instead of Mono. So when you're running on iOS and Android, you're running on the kind of against Mono APIs. When you're running in Universal, you're actually running against .NET. But to you, this should be transparent, so you don't have to worry about any differences or anything like that. Most of that Unity takes care of. And of course, you can run against Unity, or if you're running a game, you could actually run it against Xbox. And we have a separate plugin for Xbox. We have a separate plugin for HoloLens, just because those are still under development. So we actually have an extra plugin. But in the end, it's universal apps, so you should use the same application model across the board. You're just using slightly different versions of the plugins because the APIs are still evolving when we talk about those platforms. That's pretty much what we're looking at with regards to Unity. The last thing that I'll talk about is we have our own set of plugins. So if you want to use our store, if you want to use some features like, live tiles or local notifications or certain things from within a Windows game, we give you our set of plugins so you don't have to buy a third-party plugin. They're open source. You can download them from GitHub and just incorporate it into your game, and you don't have to purchase a third-party plugin if you're using Unity. So we feel very comfortable that Unity is doing really great in our store. I picked a couple of examples here of games that are running on Unity in our store. Hopefully everybody's familiar with Plague. It's a pretty popular game, PC, iOS, Android. It was very easy for them to port it to Windows and actually deploy it as a UWP. Ori and the Blind Forest is a game that's a console and PC. It's by Microsoft, and it's very popular, and the graphics are very, very rich, so you can see really great performance from Unity running a Unity game. Our store has probably 25,000 Unity games, so with regards to Unity, we feel very comfortable. They're by far the more popular middleware on our platform, and we feel very comfortable that it's working really well. Another type of game that we see a lot is people that are just coming from iOS or Android, and they have OpenGL, right? They have kind of their own custom engine built on top of GLES because they had something in-house or something like that. And what we do there is we give you Angle. I don't know if you're familiar with Angle. Angle is actually an open source project created by Google. They did it in order for them to write their Chrome browser. So they actually kind of like created these library that actually just takes all OpenGL APIs and it maps them onto Direct3D, and actually you're writing code that looks to you like you're calling OpenGL, but underneath they're translating that onto Direct3D and then just running it against Direct3D. So it's very popular. It's actually pretty popular on Windows now, and it's open source. So what Microsoft has done is we've become a contributor to it. We have full-time engineers dedicated to actually writing or contributing to Angle, making sure that universal apps are running really well on Angle. So on that side, we feel, again, very comfortable that we're doing the right things and that we have the right functionality there. You can go here and, if you go look at that link, you'll be able to find the open source port for us. You'll be able to download the templates. You'll be able to download everything you need to get started. We have a good set of templates, NuGet packages, so you can get started with Angle very quickly. With regards to implementations, across the board, we have really good implementation with GLES2, which is mostly the most common API used for mobile applications today. There's a lot of GLES3 now APIs are surfacing. iOS, for example, is starting to use GLES3 because they have more advanced hardware. And on our side, we can actually do most of GLES3 already. The only thing is that it requires a different hardware feature level than some phones have. So you need to make sure if you're using GLES3 that you're actually running against the right device and doing all the right things. Again, we default to software rendering when we fail to create something, so we should have a fallback. But if you write a game with OpenGL, you need to make sure you understand what you're doing with regards to what we're using or not. Some examples of games that are using Angle. King has brought all of their games like Candy Crush Soda, Jelly, Paradise Bay. They've brought all of their games onto the platform using Angle. There's also Game Insight has several games from the platform. Hopefully everybody here knows Game Insight is one of your local game publishers here. And they have several games in the platform. They have some using Unity. They have some that are using Angle. So there's a good scenario there where you can ask local people how good both the platforms are. And again, Game Insight has about 20 games on our store, so it's been pretty easy for them to port their games onto our platform. The last middleware that I'll talk about today, just because I picked only the 3 more popular that we see a lot, it's Cocos 2D X. Right? Cocos 2D X is kind of like the portable version of Cocos 2D, and we've had really great support for it for the last 2 years on all of our Universal, on our Windows Phone, and Windows platforms. So for Universal games, which are the ones that run across all HoloLens, Xbox, and phone and PC, we actually had the support since the version of 3.8 of Cocos 2D X. So it's been around for a year or so. If you need to backport to all their APIs, some people, for example, Cocos 2D X had this big gap where a lot of people stayed on 2.5 or below. Other people moved to 3 because it was a significant change in API models there. We do have open source projects that you can go look at code and backport your APIs, but our support is obviously looking forward, in which case we're looking at the latest versions of it with regards to what we support and what we do. So it's pretty simple. I picked here a couple games. Hill Climb Racing is a very popular game, both on iOS, Android, and Windows. So I picked that one as one of the examples. Leps World is actually pretty popular. They have Leps World 1, 2, and 3, and it's also written in Cocos 2D X. We have a lot of there's probably 10,000 games in our store that are using Cocos 2D X. So again, we know the application model works. I only covered some of those middlewares. There's a lot more. If you're looking at, hey, what are other engines like Marmalade, or what are other portable graphics engines that we have, feel free to ask me afterwards. And I'm also not going to cover a lot today with regards to, like, for example, user acquisitions SDK or ads SDK. But overall, we feel that the ecosystem with middleware is coming along, and that we have at least 1 or 2 APIs for everything that you would need, whether it's user acquisition or ads or mediation or analytics or anything else. We feel that we have a fairly decent subset of all the popular middlewares out there for games. So the last thing that I'll talk about today is this thing we call bridges. And bridges is kind of the term that Microsoft is using to bring other technologies onto our platform. So we mainly have 3 different bridges if you're looking at what you could be doing. If you want to target the universal platforms, we have bridges for coming from the web. And those are pretty simple. Those are probably not worth talking about too much, simply because everybody knows that the web, HTML, even WebGL are very portable. So if I tell you, oh, we have a bridge to bring WebGL code, you'll be like, well, it's a browser, right? So we're pretty much giving you a web view like everybody else, and that's it. But then we also created a new bridge for Win32 and .NET, and I'm going to show you a little bit more. And then we also have a bridge for Objective-C. So the first bridge that I'm talking about is what we call Project Islandwood. And this one is actually, it would allow you to bring your Objective-C code exactly as you have it from iOS and actually write a Windows game with that. So we're literally, like you can take your Objective-C, it can actually reference, UI kit, it can reference, core animation, it can reference all the standard iOS APIs, and actually we can compile it and create a Win32 application out of that. How does that work? Well, for us, it's pretty simple. We use Clang compiler, so we're not doing any trick. It's Clang just like you would have in Mac OS when you're compiling your iOS application. And then we actually compile it to native's code. We can actually compile it to x86, we can compile it to x64, and we can even compile for ARM for our phone. So we're actually taking, standard Objective-C and just compiling it. The APIs that you're compiling and linking against, we have our own versions of the iOS libraries. So here is interesting because, for example, like again, core animation, we probably have our own implementation for it, or UI kit, we have our own implementation for it. Now, there's certain APIs that are like Apple specific that we would never be able to implement, like GameKit, right? So you have to, when you bring an iOS game to Windows using Islandwood, you do have to pay a lot of attention to what API you're using and make sure that it's compatible or not, that the API is implemented. Islandwood is open source, so it will be easy for you to actually go look at the API, see what our compatibility is. We're still building it, so we can tell you, I can tell you today, we're very far from 100% compatibility across all APIs. We're working on it, and we'll continue to work on it. We've actually done several exercises. There's lots of, or a few games, not lots of games. There's not thousands or anything like that yet, but there's games that are already shipping with iOS. With Islandwood. So, for example, we ran an exercise with Game Insight. I'm not going to show you that demo, but Game Insight has Mystery Manor, which is one of their Cocos 2D games, and we've actually ported the game, and we demoed it at one of our conferences last month. I'm not going to show it to you just because I want to save time, but we're getting pretty compatible with regards to making sure we have good coverage with our APIs. Again, if you want to see how it works, this is kind of how it works. The first thing that you do is we do have our, it's Objective-C compiler, so it's the Clang compiler as you're familiar with it. And then we actually make sure, with regards to code generation in our world, we give you ARM, we give you x86, so you can actually compile for running on Windows and running on phone. And then we give you our own version of Live Objective-C. With regards to the iOS frameworks and toolings, we give you our own implementation of that. Again, most of the APIs, like especially for games, all the APIs that you would expect, a lot of them are actually OpenGL, and that's what we use Angle for again. And then the other ones that are lower level, things like core animation or certain graphics libraries, we just implement on our own. And actually, again, they're open source, so you'll be able to see which ones we're implementing. And then you use our tooling to actually compile and generate everything. So you do need your source code. You will compile it in Visual Studio. You will generate an x86 file. You will be able to debug. You'll be able to do everything the way you're familiar with regards to building any other Win32 app. So on that side, we should be okay. Like, it should be familiar to you and how we do it. And then you end up with a UWP app, and that UWP app can actually access Windows APIs too. So for example, like I talk about a game kit, we don't have a game kit implementation, but if you want to use Xbox Live, you can actually just, from within your Objective-C, reference APIs that would call onto Xbox Live and actually link back and forth with regards to bringing your own standard WinRT APIs onto your Objective-C code. Very much like when you write Objective-C and C++, where you can go back and forth, you bring headers, and you can mix the languages, we let you do something similar. So it'd be pretty easy for you to actually do that if you're looking at Islandwood. Again, Islandwood's still under development. I'm not like, if you have an Islandwood game, I highly encourage you to go to the website and try it. We have an analysis tool right there where you can submit an IPA of your game, and we tell you how compatible we think we are. So we do kind of a binary analysis. We don't need to look at your source code, and then give you kind of a summary of, oh, we think your game is pretty compatible. Here's some of the APIs that we would be missing. So you get a very good idea of how portable your game would be and how easy it would be to port it to Windows. And again, we use that data, the data that we gather from that. We will make a list of all the APIs that we're missing for you, and then we'll continue to, as we implement new APIs, we'll prioritize them based on what we're seeing from the people that are running the tool. So it's far enough along, you should try it, but I'm not going to, I can't tell you that, oh, this is ready for everybody. The more complex games, the way I think about it, the more modern APIs you have, the harder it is for us to have the implementation already. So for example, we have no support for Metal. But very few people are using Metal now. So on that side, if you are actually have standard or a standard iOS game that's 2 years old, you should be able to find pretty good compatibility with regards to island mode. The other bridge that we have is this one we call Centennial, and this one is the one that brings Win32 and PC games onto the universal platform. I don't know if you were here earlier on the session that Neil Leslie did, but we gave you a little bit of a high-level view of what that works. This is a big deal for us because we know that when we created this Windows 10 platform, we left hundreds of thousands or potentially millions of games that people are writing that are actually cannot run on Universal, cannot be submitted to a store simply because they're using Win32. And with Centennial, that's exactly what we're going to do. We're going to give you something where very, very quickly you can actually take your Win32 game, not modify your code, and bring it onto our store and take advantage of all those monetization features that we have on our store without having to do a lot of work, without having to touch your game. So when you see a demo in a minute of how we do the Centennial projects, and I'll show you exactly how, for example, I'm the one that did the Dreamland work that you saw in Leslie's demo, so I'll walk you through exactly what we did and what we changed. But here's what you should expect. If you actually, write if you want to, you have your Win32 code, you bring your code onto our model, and then we make it a universal application. You can reuse your code, you get our deployment model, which is, and for our store, we have a deployment package very similar to everybody else who has a store. We do the encryption, we do the security, we do the licensing, all of the benefits. We give you the identity, so you can do push notifications. All those benefits of a universal app, you're going to get for your Win32 app. So you actually get everything that you would expect. There's no disadvantage to using Centennial. The only potential disadvantage to using Centennial that you can think of is that because it's Win32 code, we don't run that on ARM. Right? You're bringing your binaries, so your x86 code is not going to run on ARM. So we don't have support yet for Windows Phone if you're doing these. But most of the market, if you're familiar with Windows right now, there's a huge market for Windows 10 apps. There's 300 million active devices out there. So if you bring it to Win32, you still be able to reach a very large number of people without having to do any work. So I give you what's for what universal benefits you get. You also keep a lot of your universal benefits and constraints from running on Win32. What you should know is this. If you bring your Win32 game and you run it under Centennial, it's going to run under user mode. So what that means is no admin requirements. So if you have a game that requires that you run as admin, you won't be able to bring it into Centennial. Most games usually, at least, if you look at, Steam or other games, a lot of them require admin for installation. On our side, we abstract all the installation for you because you're using our deployment model. So on that side, you would not need it, and you would be able to run fine without admin. So no elevation for the game. The advantage of it is you get to use your Win32 games. So, for example, earlier when I told you, we required it for you to run a universal game, you actually do Directory 11. When you're using Centennial, you don't have that requirement at all. You can actually do a DirectX 8 or DirectX 9 game, and we wouldn't enforce it because you're accessing Win32 APIs. So when you're writing a Centennial game, you're actually just being able to access anything that you're familiar with in Win32, as long as it doesn't require elevation. So you'll get a lot of that. So let me show you what we've done here, and I'll walk you through exactly what we did for Dreamland. I did this so last week when I knew I was coming here, I reached out to our local team And I said, hey, like, if we want to demo Centennial, can you get me some source code or some games for, local game publishers here? And one of the guys, Neversoft, actually said, oh, here, we'll give you source code to a game, for Dreamland, which is a game that's been around for a while. It's like probably 5 or 6. From my looking at the code, it looks to me like it's 5 or 6 years old. It's in Dreamland version 4 now already. So, and the code base hasn't changed that much. So, so on that side, you're looking at, for example, right here, they sent me a binary only. So I did not get their source. Like you should not need the source. And if I look at it here, I got a binary only. I started with a binary only, and I tried to wrap that, and that worked fine on its own. So I literally got a zip file that included all the binaries here. If you're looking at here, the game is actually running on DirectX 8. So again, it's a Win32 game. It's DirectX game. It's DirectX 8. And we didn't have to touch it. We can actually run it as a universal game. How we convert the games is pretty simple. For a game like this, that actually it's kind of what we call an Xcopy install, something where you don't have an MSI to install it. All we need to do is create a manifest. So I went back here, and I created a little manifest, which is an XML file that we can use here. And I'm just going to say, edit this guy right here on Notepad. And you'll see right here, actually, let's see if we can change the font for you to see it a little bit better. So all you have to do here is literally, I went in there and I gave it an identity. So here's the name. It's kind of like the unique name that we're going to use for publishing to our store. Sasso is the name of my publisher, and then Centennial Test 01 was the name I gave this one. And then obviously you have to give it a version so that when you submit it to the store, we know how to version it. You can submit later ones or submit updates to it. And then here, let me just go bump to version. So we can reinstall it if we want to. And then the next thing that you have to do is you got to give it some assets. So for example, right here, I defined 3 or 4 assets that I went in there and I added so that I would have the visual elements so that I could put it. Oops, sorry. 1 second. Thank you. So then let me show you. So I have the binary right here. I show you all I got were the binaries right here for them. And so here's their binaries. You can see they're executable right here. It's a DirectX game. I added this manifest file, which is the one that was just edited, that I was just editing here. So, and all I did is I gave it a unique name. So this is kind of like the unique name that we're going to use in our store. We call it the identity. The publisher name is who I'm registered for in the Windows Store. And then I added a few assets here, like, extra assets that I needed, like a 150 by 150 logo or a 44 by 44 logo, which are the ones that we use right here. So for example, if you look at our start menu and you want to pin a game to these right here, you need a specific size of icon, and that's the icons that I gave it. So I just added it as a package right here. And then I was able to actually literally take that same executable and run it now. And it's now a package that can be submitted to our store, right? So if I wanted to do here, for example, I bumped my version here. Let me just save it, right? And I can just say, actually, I have this batch file. That does 3 things. If you're looking at here, I have a batch file that does 3 things. It's actually calling make Apex. Apex is our package format. So when you submit something to a Windows Store, we have this package that we call an Apex. It's very much like, if you write an Android game and you have an APK, it's the exact same thing, right? It's one zip file where we just use that as a container for everything. We call them Apexes in our world. APK or IPA on iOS is the equivalent. So all I did right here is I ran a command to actually take the binaries that are in that directory and then just make an Apex out of that. So right here, make Apex is a command that comes with Visual Studio. And I can actually just say packet and actually give it the directory name that I wanted to run. and then I sign it so that it knows that it came from me as the publisher. The sign-in right here is optional because I'm going to, like, the reason I did it this way was because I wanted to deploy it locally. If you submit it to a store, the store is going to sign it for you, so you shouldn't have to re-sign it if you want to there. And then I actually added the command right here to actually install the package locally on my machine. And to show you that one running, I just need to open a command prompt right here. That's Visual Studio because Make Apex was not on the path from that command prompt. So I can just right here come back and say Centennial, make Dreamland batch. And this is right now going to go in here. It's asking me if I want to override my Apex because I had one from the previous demo, and it's just saying yes. And right now, all it's doing is copying all the assets from there and making a zip file or an Apex file out of that. That's the package format that we submit to our store. So you'll see it right here. It's going to create the Apex, the actual package format, and actually it's going to actually right now sign it, right? And and now I have a package that right here. If I go to packages, you'll see right here, there's a dreamland.apex, which is literally what I would submit to my store. So if I wanted to submit this to the Windows Store, I would actually just go to the Windows Store, to the developer portal, and submit that again, very much like you submit your APK or your IPA file on Android. So it'll be very straightforward for you to do that. If I wanted to just install it right here, and this game is already installed, but I updated the version. So if I wanted to just install it, I can just come back here and go to PowerShell and just say add Apex package, oops. And just do Dreamland. And then that will actually, because I updated the version, it's just going to install it on top of the old one because it thinks it's a new version. And then I'll be able to run it. Now with that API, and because I have the identity that I need for a store, now I could do things like add in-app purchases and communicate against the Windows Store. I could go in there and, for example, do push notification against this package, and I can actually create a little tile. I can actually do everything here. It looks like this failed. I must not have saved the version that bumped it and updated it. But you saw these, like, the package is there, and actually the game is already installed. That's why I got the error on red there, because I didn't update the version. It's just saying that it's the same version that I already had. But again, that's how easy it is to bring your Win32 games onto the store. This is a brand new feature. This is, for us, is very exciting because, again, one of the big constraints that we got from for game developers over the last year was that everybody came to us and said, hey, I have my Win32 games, but I can't bring them onto your store because you don't have a way for me to bring them, and I don't want to rewrite them. For example, just Nebusoft, like, they had 150 games that they're like, hey, if Centennial works, we'd be happy to give you our top 150 games. There's all sorts of publishers here in Russia, for example, Alawar, other ones that I've talked to this week, who said, oh yeah, we have hundreds of games that if this technology works, we can bring them onto your store very quickly. So we're pretty excited. The technology is going to come out, like right now, what you're seeing here, it's available in the developer preview, but Centennial games are actually going to be available in the summer as we update the new version of Windows, and we have what we call the anniversary edition comes out. That's when you'll be able to submit Centennial games onto the store. But it's going to be, again, it's very simple for you to update your game, and it's very simple for you to bring it onto our store and actually take advantage of new functionality. So on that side, we're really excited about being able to bring more games. If you have Win32 games, talk to us. Now, I showed you the very simple, the Dreamland game that I showed you was very simple because it was like literally an Xcopy, right? It was a zip file that they sent me all the binaries, and I didn't have anything else. If you have more complex games, like you have something that has an MSI, and it writes to the registry and does other things, we actually have a tool called Desktop Application Converter, where you give us your MSI, and then as long as your MSI does not require admin, we can actually run your MSI and then actually literally see everything that is changing, like all the registry entries that is changing and everything else. And then we create a specific Apex manifest automatically for you that is going to make it work with all of the things that you were doing already, right? So we make sure we we give you this app container where we say, okay, when your game gets deployed, we're going to pretend that all of the registry entries and all these things are updated such that your game still runs. We do that in an isolation mode where we're not really routing to the registry, but to your game, when you look at it and when your game runs, it looks exactly and it runs exactly the same as it would if it was a Win32 game routing against those things. So, so you would be able to just deploy your game and very quickly, or run your MSI against it, create the manifest, then create the Apex like I just showed you, and then submit it to the store. So there's nothing that you would have to do as long as your game does not require admin. So, so that's what we're looking at. Now, with Win32 and Centennial apps, the other thing that we do, obviously, if you have your Win32 game, and then you just repackage it, submit it to the store, you're going to want to add some APIs, like, again, in-app purchase or other APIs. So what we do there is we actually just give you the APIs. We give you APIs where you can say, okay, if you want to include all these APIs on your Win32 game, you can do that. So we have different models where you can say, basic thing is like, hey, take your API and add a little bit of functionality. So you extend your game by actually just injecting APIs. Like if you just want to add purchase or local notification or something like that, you go into this model where you just say, oh, I have my app, and I'm just going to call some APIs, and I'll be done. You can do more complex things, like you can actually create new UIs, like actually start creating modern UIs and actually communicate back and forth, do background processes and other things if you want to go beyond what your game can do, so you can start porting it to Universal. But you know, those are not required, so for the most part, you can just bring your game very, very quickly, take advantage of a few new APIs, and be done. You know, and that's what we're looking at for. So that's pretty much, you know, kind of my intro to Universal Platform. That's what you need to know if you wanted to bring our games. We talked mostly about how you can take Windows Core, which is the one API that we have, and making it available to, you know, target devices that are IoT or HoloLens or Xbox. I didn't show you HoloLens today, but everything I talked about will be applicable to HoloLens. So it's the exact same thing, that like the exact same game that I showed you running here on phone, Xbox, and PC. Can actually run on HoloLens, no problem. You just have to look at the input factor and everything else. And with that, that's pretty much what I had to say. From a Microsoft standpoint, we want to tell you that you know, we are very committed to games. We want to make sure that games is #1, the best place for people to play games. So DirectX 12, you know, sensors, you know, gamepad, all the things that you need, HDR. Those are features that we want people to take advantage of when they're playing their games. We also want to make sure it's the best place for you, you know, for you to develop your games. I talk about Visual Studio, some of the new gaming features that we're adding, and then the last thing is we want to make sure we give you services like Xbox Live, so you can take advantage of when you write your games, making sure that you have the most immersive games ever. And with that, I thank you for staying here. Feel free to drop me an email or contact me on Twitter or whatever if you have a question afterwards. I probably have like 1 minute for questions, or no minute, 3 minutes. Okay, so if you have a question, feel free to, you know, ask, or come back afterwards and I'll try to, you know, walk with you out of the door so the next person can present their session. Thank you very much for coming. And again, there's a store session tomorrow, so if you want to read that one, you get to learn a lot about the store tomorrow. So, thanks.